When we weld two pieces of metal together, we're worried about how that weld is going to affect the properties of that metal. Today we'd like to show you how the process is to test the tensile strength on welded aluminum. The tensile strength of 6061 aluminum is around 46,000 pounds per square inch. So what we want to do is we want to take two pieces of aluminum, piece 1 and piece 2. We're going to put a bevel on each one. And with that bevel, we'll come in and weld this up solid with a weld. Now our interest is going to be, how does this area right here, how was it affected with that weld on there? Did we lose strength or ductility? We know the base metal properties right here. So now we need to find out, what did the weld metal do to that piece of metal? So we want to put it in tensile strength, and we're going to pull it. Now, it's unlikely that we're going to be able to pull a great big bar that we've welded together and pull it apart. So we've got to make a smaller piece. We'll come in here and we'll take a slice out of that bar. And we're going to machine these grooves in it there so that we can isolate this area as the breakage point. The weld will still be right here. And then we can put it in the tensile machine. The tensile machine will do 20,000 pounds of force. So 20,000 pounds would be inadequate to pull something that needed 46,000 pounds. And that gives us 1.5 inches wide. So we'll cut 1.5 inch wide strips out of our part and then machine 1/4 inch on each side. And we will have our dog bone that we can put in the tensile machine, which it's over here, and we'll show you that a little bit later. With our piece cut through, we can see we have a nice 45-degree bevel. So after we cut the first 45, we came in and cut the second 45 on the other side to create a bevel. That bevel will help us to weld on both sides so that our plates don't bend up and warp in one direction. We can balance the stresses from each side. So what we're doing here is we're degreasing the aluminum. Any kind of grease or cutting oil that could have been picked up from the saw, even though we didn't have the coolant on, could be in the surface of the plate or from the mill when it was being produced. And we are degreasing before we grind anything so that the grinder doesn't add any problems to that. We want to grind the saw blade edge cleaner. We would like it to look a little bit more like this, smooth, just to eliminate some of the ripples and things that could cause fusion issues with the welding process. So talking a little bit about grind disc, this one here is dark. It's for steel. This one is a lighter color, but you'll see it's actually a grinding wheel for aluminum. It's got a softer binder, which allows it to break off quicker and not build up. If we were to grind aluminum with this one, the aluminum embeds in there, and then you're grinding aluminum to aluminum. This one, as it embeds in there, they chip off, and it keeps going. Then for a final pass, a final smooth pass, we'll use what's called a flapper wheel. 80 grit, and it's just got sandpaper on this side. We'll put this one on to smooth out first, and then we'll go to the flapper wheel.
Pretty good.
Very nice.
And then thickness.